Okay, so in this video, I'm going to start explaining counting and probability AoPS challenge problem 5.17. Okay, the problem reads, in a diagram shown in figure 5.16, which is this figure, note that the grid path from F to G is missing. So paths from D to E cannot pass between F and G. How many paths are there from D to E? Assume that all paths have steps going up or to the right. So what I'm going to do first is they gave you 3 hints. They gave you 3 hints, so you should have looked at these hints. If like you didn't know how to do, the best way is to look at the hint and try to think about it. So I'm going to tell you what way you would want to think with these hints. So in future hints, you know how to think for these types of problems. Okay, for hint 1, it tells you to use complementary counting. So what's complementary counting? Complementary counting is when you take the total of some cases and you subtract the minority, something smaller than that. And that's what you do. You count what you don't want. Okay, so first think about what could be the total and what could be the subtracted part. So what do we see is missing? F to G. So that might be a possible thing that we can work complementary counting on. And then another way you can think about it is, what is the minority in the total figure? The second and third hint are the same. The second one just tells you the longer version of the third one. The second one reads, imagine the missing line is filled in. Count the number of paths from D to E without restriction, and count the number of paths from D to E, which use the path from F to G. So what it's really saying is fill in FG and do complementary counting. So what hint number 2 is saying is just explaining the idea of complementary counting in this example. This is pretty self-explanatory, but count the amount of paths using the formula. But you should know the reason of this supposed formula. So I'll just start explaining the reason for this formula. So we're going to take example, this picture. We want to go from A to B. Let's say, for example, just going there. One example of how to go from A to B is to go up 1, go to the right 2, go up 2, go to the right 3, and then go up 1. What you realize is that every path going from A to B has to have 4 ups and 5 rights. So you can try any case, but every case has to go at least, no, not at least, it has to go 4 ups and 5 rights. You can't go 3 ups and then just go 5 rights. For example, like if you try that, go 3 up, 5 right, you still have to go up 1 more to go to B. So what after a while you just realize, oh, it has to be 4 ups and 5 rights. So at the end of the day, we find out that what matters is the order of these 4 ups and these 5 rights. How to solve this? It's like ordering a word. For example, Alabama. What you do is just find the total letters and divide by the letters that are repeating to the factorial. So this is going to be 9 factorial divided by 4 factorial times 5 factorial. This is because there's 4 U's and these U's are exactly the same. And for the R's, exactly the same. So it's going to be 9 factorial divided by 4 factorial times 5 factorial. All right, let's get a harder example. We want to go from A to B without going through C. So really, there's many problems on this, like the AMCs that I've seen, but it might have changed in the past years. And if so what it's going to be like is like C has some kind of poison, and A is a person, don't want to go there, and it has to go to B, which is another person or location. So these problems are like fairly common. So what you want to do is first complementary counting. As I defined before, it's count what we don't want, and we subtract that from the total. Okay, so the total is something, and then you minus going through C, because you don't want going through C. Total is easy. Just count the paths from A to B, and knowing what I just said and taught you about ordering a word, this should be fairly easy. Going through C is moderately harder. It should be quite easy after this video, but yes, without learning it, it is quite hard. What to do is first count the paths from A to C, then to C to B, because you want to know how many paths can I take that A has to go through C, and then what paths from C do I have to go to B. Multiply these two numbers because these are two separate cases. If there's two separate cases, you always multiply them. Okay, now let's move on to the problem. Do the same thing as this problem that I gave you. Complementary counting. Of course, subtract what we don't want from the total. Total minus paths from D to E that go through F and G. So let's pretend F and G is a line. So I'm just going to quickly draw a line. This is just one line. So now it's easy. It's exactly the same as the problem I have given you in the past slide. So go from D to E, D to F actually, and then F to G, and lastly G to E. Because you want to know it can't go through F and G since there's no line. So there's just one more case in the last problem. So D to F, F to G, and G to E. Multiply these three cases now, since these are three separate cases. All right, so total cases equals to 3 ups, 5 rights. These are 8 total moves, so it's going to be 8 factorial divided by 3 factorial times 5 factorial, and I've solved it for you, it's 56. All right, so then 56 minus D2F. D2F is 2 ups, 2 rights. 4 choose 2 equals 6. F to G, that's just one line, so it's just one. Pretty self-explanatory for that one. G to E, 1 up and 2 rights. 3 choose 2, because 2 plus 1 is 3 moves, so 3 choose 2 equals to 3. 6 times 1 times 3 equals to 18. 56 minus 18 is 38. So the basic, just to summarize, what you want to do is complementary counting. And these are like called grid paths. And so you should know exactly how to do these types of problems for after this video, because it's fairly common, but I'm not sure in the past years. In the future years, maybe it's not going to be that common, since in the past AMCs they had it. They probably won't use the same problem again. But these types of problems are common in math competitions and math sets in this younger years. Yes. So these problems are important to know how to do. Thank you for watching and have a great day.